It was while surveying the area that de Boer spotted a road crew widening the road.
They had excavated part of the road and they had exposed a beautiful fault plane. And I thought to myself, hey, this is sort of interesting because I see evidence for a fault to the west of Delphi and I see evidence for a fault to the east of Delphi. Logically, they should be one and the same fault. All I have to do is sort of trace one east and the other one west and hope that they can connect. And I did that.
De Boer hiked for miles, tracking the fault line. Satellite photos later confirmed his suspicions.
Once you have the help of the satellite maps, it's very, very clear that this fault continues all the way east, below the town of Delphi, from very below the oracle site, and then continues all the way to Percora.
The presence of the fault line corresponded with the earliest known accounts of the powers of the oracle, dating back 1,700 years before the birth of Christ. It was this common phenomenon the French archaeologists might have missed.
They found just one layer of clay after the other and one layer of rock debris after the other, and they became quite disappointed and they dug deeper and deeper into it, and then they said there is no big cave. But the Greek word for cave can be translated in different ways. It can also be a fracture or a vein or something like that.
To confirm his suspicions, de Boer re-examined the original photographs taken by the excavation team.
And so I went over those photos, and I saw that in those layers, actually offsetting some of those layers, were cracks that were probably not more than half an inch to an inch wide. And they sort of ignored those as insignificant cracks, they call them, that were running through there. And that's, of course, the most perfect fracture that you can have for water to rise up and for gases to rise up.
But what kind of gas could have caused the trances, the frenzy, and the prophecy so long associated with the oracle? If a chemical culprit could be found, science would come one step closer to solving this ancient riddle. Of the thousands of petitioners that consulted the oracle at Delphi, few were given an unequivocal response. Most prophecies came in the form of cryptic verse. The wording was often obscure, and misinterpreting the oracle could be deadly. The case of Croesus, king of Lydia, in what is now Turkey, was typical. In 550 BC, preparing to invade Persia, Croesus consulted the oracle. He was told, "If you attack, you will destroy a great kingdom." Croesus attacked, only to trigger a massive retaliation. The prophecy was fulfilled. Croesus had indeed destroyed a great kingdom, his own. Like all who petitioned the oracle, Croesus had to walk past an inscription on the temple, 2 words that could be read as an exhortation or a warning. Know thyself. No matter what else a Pythia revealed, each petitioner ultimately had to find their own answers. In the summer of 1998, Hale and de Boer returned to Delphi for a second time to complete their own inquiry. They intended to prove that the source of the legendary oracle's powers was not a myth, but a geological and archaeological reality. To take their investigations further, de Boer and Hale petitioned the Greek government for unprecedented access to Delphi. Working with the site's archaeologists, they conducted a detailed geological field survey that ended months of speculation. Under the Temple of Apollo, de Boer and Hale found not one fault line, but 2.
Behind me is the exposure of a very large major fault that's also known as being active. We named it the Delphi fault. Now, aside from the Delphi fault, which sort of trends east-west here, there is at the oracle site another fault that trends north-south, and the 2 intersect.
The point of intersection, forming an almost perfect X, is Delphi. But how could they prove it ran through the sacred Adyton itself? To find the answer, the scientists searched for evidence in the water pushed up along active fault lines.
One of the first things we saw were big mounds of a rock, which is known as travertine, which is a rock that is formed above springs when the water, which is warmer and at deeper level, comes to the surface and cools. And so that meant, of course, that there were quite a number of springs.
Using flags to mark each point where there was evidence of spring activity, a pattern soon emerged.
They seemed to be on a line, and that line was sort of a northerly-southerly kind of line cutting through here. And so it became very obvious now that you not only had the fractures, one, but you also had groundwater rising along those fractures and forming these mounds of travertine that we find so abundant on the site and has been also being used in the construction of the temple.
An examination confirmed that the temple was built on an ancient spring, one that was active at the time of construction.
One exceptional feature of the Temple of Apollo is the fact that a system of drains, pipes and conduits crossed its foundations, bringing water from springs further up the slope through the foundations of the temple to the Cassiopeis fountain situated immediately to the south of the temple.
It would be crazy to build a temple on top of a spring unless you needed to. This foundation is actually punctured by these conduits for water, and to have active water coming up into your building, into the very foundations of your building, is not a sensible thing to do if you're interested in solid, secure foundations.
An interesting architectural feature of the Aditon is the fact that it does not coincide with the axial line of the temple, but instead it is slightly pushed to the south, slightly off-centered, as it were. I think the best explanation for this positioning would be to say that the sanctum aimed to shelter a specific geological feature, such as the fissure.
As Hale discovered, Delphi was not the only Apollo temple constructed on and around a geographical feature.
In Asia Minor, what is today Turkey, there were oracle temples, such as Claros and Didyma, deliberately built over springs. And most extraordinary of all is the example of the Temple of Apollo at Hierapolis in Turkey, where a similar opening in the foundations was a vent for subterranean gases and emission of CO2 so toxic that any small animal wandering into its path would be killed, and when I visited the temple there were still dead sparrows all over the ground.
But the gas released at Delphi was not toxic. Instead, it appeared to have an intoxicating or narcotic effect. So what gas was it?
And that is a very difficult thing, obviously, to try to prove, because gases, well, you know, they come to the surface, evaporate, go up in the atmosphere, dilute, and that's it. They're gone forever.
It was the travertine, found at what is believed to be the Pythia's underground spring, that provided a plausible answer.
Travertine is a calcium carbonate rock that's formed very rapidly when a spring comes up from underground and pressure is released. And when that happens, CO2 is degassed and calcium carbonate precipitates. And this happens very rapidly.
This travertine material that you see in here actually is extremely porous. It's like a sponge. You see many, many small holes all through it. And that means that in those holes it is possible that some of the gases, which theoretically rose with the waters, were captured. And what we need to do then is take samples of the travertine. They need to be crushed, and then those gases hopefully will actually be released and we can analyze those chemically.
Environmental chemist Geoffrey Chanton took water samples and tested the travertine.
We took these rock samples and we chopped them up into small little pieces and put them into a flask. First we dissolved the rocks with acid because it's a carbonate rock, and so in acid it's quite soluble and it dissolves and liberates all the gases.
What Chanton found would go far to explain the mysterious events at Delphi, but only after his scientific quest took several unexpected turns.